Okay, let's dive into this. You've probably played around with large language models, right? Seen them write emails, summarize things, maybe even brainstorm. They're really good with text.
Oh, absolutely. Understanding language, generating it, fantastic. But the real kicker is getting them to do something with that understanding, in the actual world.
Exactly, like not just telling you about turning on a light, but actually flipping the switch, metaphorically speaking.
Yeah.
Or maybe literally running your code.
Right. And that's where this thing we're looking at today, Microsoft's Semantic Kernel, comes in. The Quick Start guide we checked out really positions it as that bridge.
Yeah, the bridge between the AI's brain and, well, your stuff, your systems, your code.
Think of it like this. You give the AI some tools, maybe a wrench, maybe some software functions. Semantic Kernel isn't just the toolbox, it's also kind of the instruction manual that helps the AI figure out when and how to use your specific tools.
Okay, so our source today is that Python Quick Start guide. And our mission really is just to pull out the essentials from that guide. How do you get started, connect the AI, and crucially see it call your code? That core bridging idea.
Yeah, nail down that fundamental concept first.
So where does the guide say to start building this bridge, I mean?
Well, the first step, pretty logically, is getting the software. The Semantic Kernel SDK, it shows the standard Python way pip install.
Right. Pip install, upgrade semantic kernel. Nothing too surprising there for Python folk.
Nope, straightforward install. What's maybe more telling is the initial code setup they show. You import some standard libraries, Asensio, stuff like that,
Right.
but then you pull in the key semantic kernel pieces.
Okay, like what are the absolute must-haves according to this quick start?
You definitely need the kernel itself. That's the orchestrator, the core. And you need something to represent your connection to the AI model, like in this case, Azure Chat Completion.
Gotcha. And maybe something for the chat itself.
Yeah, and chat history to keep track of the conversation. Plus, importantly, kernel function, which we'll get to. These are the building blocks.
Okay, so the kernel's the heart of it. How does it know which AI to talk to? There are so many models out there.
That's the next big setup piece in the guide. Configuration. You have to tell the kernel where your AI lives. The example uses Azure OpenAI, so it shows setting up environment variables usually.
Ah, right. Things like your deployment name, your endpoint URL, the API key, or authentication method.
Exactly. It's like giving the kernel the specific address and, the keys to your AI model's front door so it can communicate securely. You'd plug your own details in there, obviously.
Makes sense. And setting up the kernel itself seems almost too simple. Just kernel.
Huh. Yeah, initializing it is easy. But its power comes from what you add to it. First thing you add is that AI service connection we just talked about.
So you create the Azure Chat Completion object with your details, and then you add that to the kernel instance.
Precisely. That's how the kernel knows, okay, this is the specific large language model I'm going to use for requests.
All right, kernel initialized, AI connected. Now, before getting to the really flashy stuff, the guide brings up logging almost immediately. Why focus on that so early?
Oh, that's super useful. It's basically your peek behind the curtain. By setting the logging level, like to debug as they show, you get this stream of information from the kernel.
Like what kind of info?
You see the request coming in, you see the kernel thinking, do I have any tools, any plugins that could help here? You see it maybe calling a function, you see the response forming. It's invaluable for debugging, obviously, but also just understanding the flow, seeing the AI's thought process within the framework.
Okay, that makes sense. Diagnostics. Right now, for the part that really caught my eye, giving the AI actual capabilities, moving beyond just chat. The guide calls these plugins.
Yes. Plugins are where it gets really exciting. They are essentially collections of your functions, your code, packaged up so the AI can find them, and crucially, understand what they do. They're the tools we mentioned.
And the Quick Start has this neat little example, right? A lights plugin.
Yeah, very simple. Simulates controlling lights. It's a Python class, but the important bits are the methods inside, get lights and change state.
Okay, just regular Python functions inside a class. How does the kernel or the AI know these are special, that these are the tools?
That's the key bit highlighted in the guide. You use a Python decorator at kernel function. You put that right above your function definition.
Not a kernel function.
That decorator is the signal. It tells semantic kernel, hey, pay attention to this function. It's a capability I want the AI to potentially use.
Got it. So it's like tagging your tools, but just knowing a tool exists isn't enough. How does the AI know, like, what the change state tool does or how to use it? Does it need an ID, a color?
That's where the descriptions, the doc strings, become absolutely critical. The guide really emphasizes this. You write a clear natural language description for each at kernel function.
Like right in the code.
Yep. For get lights, the description is something like gets a list of lights and their current state. Plain English.
And for change state.
It's described as changes the state of the light, and importantly, it also mentions the parameters it needs, the id of the light, and whether it should be ISOM.
So those descriptions are like the mini manual for each specific function. That's what the AI reads to understand the tool.
Exactly. That description is how the large language model figures out, oh, the user asked to turn the porch light off. This change state function seems relevant, and I need to provide an ID, porch light, and set ISOM to false. It's vital.
Okay, makes total sense. So you've defined your plugin class, decorated your functions with add kernel function, written good descriptions. Then you add the plugin instance to the kernel.
Right. Kernel.addPlugin, plugin, lights. Now, the kernel is aware of the lights plugin and its functions.
So the AI knows about the tools and understands how to use them thanks to the descriptions. What's the final piece that actually makes it, run the code?
This is the really powerful part, intelligent function calling. The guide shows setting something called function choice behavior to auto.
Function choice behavior.auto. What does auto do?
It tells the kernel, listen, when you process a user request with the AI, if the AI determines that one of the available plugin functions is the right tool for the job based on its description, and if the AI can figure out the necessary inputs like the light ID and state, then automatically execute that function. Don't just suggest it, do it.
Wow. Okay, that's the bridge in action. The AI isn't just generating text saying, I would call the change state function. With auto, it actually triggers your Python code.
Precisely. It sees the user intent, turn off the lamp, matches it to a function, change state, extracts the parameters, lamp ID off state, and because auto is set, Semantic Kernel just invokes your change state method with those parameters.
And your code runs, does its thing, maybe updates a database, calls an API, or in this demo, just changes a variable.
Right. And then the result of your function running is fed back into the AI model, which uses that information to formulate its final response to the user. Like, okay, I've turned the table lamp off.
It's seamless. That's really cool.
It is. It connects the natural language understanding directly to code execution and back again.
And the quick start shows this working in a little conversation, right? It uses a chat history object first.
Yeah, that's pretty standard for chatbots. You need to keep track of the conversation turns so the AI has context. You add the user message, get the AI response, add that back. Keeps the flow going.
And they use a little helper function just to wrap that process up.
Right, just simplifies sending the prompt and getting the reply back. But the real magic with auto turned on is happening inside that call.
Okay, so walk us through the demo conversation they showed. First query, get the light state. What happens?
Okay, so you send that prompt. The kernel passes it, along with the available plugin info, including the getLights function and its description, to the AI model.
The AI looks at the prompt, looks at the function description, gets a list of lights, sees a match.
Exactly. It thinks, yep, getLights is the tool I need. Because of auto, Semantic Kernel invokes your getLights function. That function runs, maybe returns a list like table lamp on, porch light off. That list comes back from your code. Semantic Kernel gives that result back to the AI, which then generates the nice natural language response like, okay, the table lamp is currently on and the porch light is off.
Got it. It used the function to get the data for its answer. Now, the more complex one, change the state of the table lamp to on.
Right. Same process starts. Prompt goes to the AI along with plugin info. The AI sees the intent is to change something. It looks at the change state function and its description changes the state, needs id and ISOM.
And it figures out from the prompt that table lamp is the id and on means ISOM. Crew.
Yes, it performs that parameter extraction. It understands the mapping. And because auto is enabled,
Semantic Kernel automatically calls the change state function in your Python code, passing in iTableLamp and ISOM. True.
Exactly. Your code runs, updates its internal state for the table lamp. Maybe the function returns a simple okay or true.
And the AI gets that confirmation.
And generates the response. All right, I have turned the table lamp on for you.
And you can verify this, right? If you then ask, get the light state again.
Yep, the demo shows exactly that. You ask again, the getLights function runs again, but this time it returns the updated state, reflecting that the table lamp is now on, and the AI reports that back. You see the full loop.
So that quick start really demonstrates the core idea. Semantic Kernel acting as this intelligent intermediary. It takes your natural language, figures out if your code needs to run, runs it, and uses the result.
That's the fundamental capability right there. It's not just about chatting, it's about orchestrating actions based on language understanding.
Okay, so just to recap the absolute basics from this quick start. Set up your environment, connect your AI model to the kernel. Define your functions, your tools, inside a Python class, mark them with @kernel function, give them really clear descriptions.
Crucial step, the description.
Add that plugin to the kernel, and then enable function choice behavior.auto that allows the AI to intelligently decide when to run your code.
Yeah, that nails the core flow shown in the quick start. It gives you that immediate picture of how this bridging works.
And obviously, this is just scratching the surface. The guide itself mentions going deeper into different kinds of plugins, semantic functions, which sound like reusable prompts.
Right, managing memory for longer chats, building more complex chains of actions. There's clearly a lot more to it.
But this starting point gives a really solid grasp of that fundamental power, connecting language to action.
Definitely lays the groundwork.
Which kind of leaves you thinking, doesn't it?
Yeah.
If the AI can run your Python code, and that code could theoretically interact with anything, a database, an internal API, a sensor, or another piece of software, what does that really unlock?
Yeah, when the AI isn't just accessing public knowledge, but executing your specific business logic or interacting with your private data sources via these well-described functions.
What are the possibilities there?
Yeah.
And maybe just as importantly, what are the safety rails or design considerations you need when you give an AI that kind of direct operational capability through your own code? Something interesting to chew on.